Hello, Worth McAllister here. For this week's application on individual movement and dispersal, I chose the fox squirrel, eastern fox squirrel, as my species of interest for the mock research proposal. Fox squirrels are associated with mature oak pine forest. Although they inhabit a wide range of vegetation types, there's been a lot of study on fox squirrels over the year. Often these are site specific, so what's going on in the specific study area of interest. They are highly reliant but not obligate on a hardwood component. They like open understories maintained by fire. They're an interesting species because they show a high degree of pelage polymorphism, and their home range has been documented numerous times. They have interspecific niche overlap and partitioning with the gray squirrel, but they don't. That can be mutualistic. It's been shown they don't defend a territory specifically, but they do generally show solidarity compared to the gray squirrel, and of course they defend fine scale resources such as nest locations and food resources. This, as a game species, has been studied throughout the years, including recently, but with new advancements in remote sensing and GPS technology, giving us a lot of fine scale data. The uh, for this species as well as a lot of others, we are at the precipice of being able to look at use these high end models that we learn about in this chapter to understand the behavior on multiple spatial scales, whether that be home range, pseudo territories, um, or specific fine scale uh, selection of a tree next to another tree. We'll get into that more in a minute. NC State does a lot of research on Fort Bragg, which is landscape dominated in longleaf pine and wiregrass ecosystem. It's managed for the red cockaded woodpecker. They do a lot of fire out there, and NC State does a lot of studies on how animals utilize that landscape. They used VHF, high frequency data to look at home range in 2011, 2012 on fox squirrels on Fort Bragg. They used kernel density estimates and did come up with some data there. They looked at mortality. Combining that study with another study I found from 2016 is how I developed my ideas here. This study looked at next generation remote sensing data for landscape attributes combined with GPS collar data. So you can put the collars on fox squirrels now, even 10 years ago. And they came up with various multi scale models to look at how they're using the landscape. They did note in this study that there was a limiting factor because they needed the tracking technology to become more accurate, i.e., elevation using light and then combined with lidar data for understanding selection that used tree canopies. So with vertical data, we could also see where the squirrel was in the vertical structure of the vegetation, and the possibilities are endless for making inference. I think it would be particularly interesting to do that in North Carolina on some of the managed loblolly pine stands where you have a mosaic of basal areas, understory, and in a patchwork across a managed pine landscape, especially that uses fire. This is the collar they used in the study that I just showed. It's been out for 10 years. There's a new collar that came out right after they did that study that also would work on fox squirrels that's even lighter, and it uses the iridium system, which is a low satellite system, and gives you a lot of data points. Another really interesting paper I found was in Science Magazine by Roland Case. He's also with NC State and does a lot of popular media things and very well known. And he went in a little bit into the ethics of it. Of course, there are best management practices for using active sampling as opposed to passive. There's a lot of good passive techniques out there now too, but I think for this, the cost benefit analysis is certainly justified. Did I answer everything? Thank you very much.